Oh, yes. I am Ivan Желубак, Lviv Polytechnic National University. Theme of my work. Do you hear me good? Yeah.
Yes, yes.
Yes, we see and hear. Please.
Okay, thank you. Theme of my work is verification of synthesized by the IP core generator multipliers of extended Galois fields elements, and abstract the aim of the study. The article is devoted to testing the developed multipliers generator for elements of extended Galois fields. Such a generator facilitates the generation of HDL description for multipliers based on modified Guild cells which are interconnected. The number of modified Guild cells can be 2 power 999. The test result of the generated multipliers are provided for Galois fields with characteristics 3 power 37 power 17 23 power 10 53 power 8 which have approximately the same order. The testing was conducted through simulation in the active HDL environment. The simulation results were compared with the results of multiplication in the mathematical package MAPL. The article demonstrates that the created Galois fields multiplier generator operates correctly. Testing was performed using 3 Galois field multiplication architectures. It's a black box multiplier and under composite composite of primitive elements. And here we can see our multipliers that consists from elements modified Guild cells and element F. In the left picture, we can see a common using scheme of multiplier for Galois fields with characteristic P and power n. In the right picture, we can see a scheme of multiplier for Galois fields with characteristic 3 and power 3. The element f is used to find the coefficient by which you need to multiply the polynomial to sum up the intermediate result. Calculates a function that depends on two parameters. F assigned P minus GM. GM is Guild cells and module P. The results are at the output of the modified Guild cell at the direct during calculation. The coefficient of the highest degree of an irreducible polynomial is always equal to 1. And here is a scheme of Guild cell and modified Guild cell. In the left picture, we can see a Guild cell. It has 3 inputs, A, B, C, and 2 outputs. Result, S, and carry out output. In the middle picture, we can see modified Guild cells. Cell in it's like Guild cell but has no carry output. In the right picture, we can see symbol of the modified Guild cell. Next. Here we can see in right picture scheme of Galois field multiplier created in active HDL environment. It's for field Galois field with characteristic 3 and power 4. In the left picture A and B we can see modified Guild cell created in active HDL2, and A is modified Guild cell with architecture with when modified Guild cell is unified element, and in picture B modified Guild cell consists from multiplier and other. Next, here is a third architecture when modified Guild cell consists from logic elements. This modified Guild cell is built like matrix multiplier with module dividing and other with module dividing. This scheme consists from elements SMN, its Guild cell, SMC, SN, RN, and sum it's summator. We can see it here. Next, here we see these elements and we can see that element SMC consists from multiplier and other with output and carry output. SN is XOR element and RN is multiplexer. Sum element is common using element summator. Next picture. Here we can see a structure scheme of our multiplier generator. As I said, it consists from modified guild cells in 3 architecture. Modified guild cell is a unified element. Modified guild cell consists from multiplier and other, and modified guild cell consists from logic elements. And element F is used for these 3 architectures. We can see here that it is created here in top of this picture here. We can see logic for creating modified guild cell here and here. And logical function for it. For first architecture, we create modified guild cell here, and for second architecture, we create modified guild cell. But for second architecture, we should generate Boolean function for element sum and for element mul. After it, we minimize this function and generate visual description of this modified guild cell. If you take a third architecture, we should generate Boolean function for elements sum g, its summator, SMN, SMC, element SN, and element RN. For every this element, we generate Boolean function, minimize it by Quine-McCluskey method, and after it, we create modified guild cell. After we create matrix of elements F and matrix of modified guild cells, and from this matrix we generate our multiplier. And here we can see created our generator. We have here fields for enter characteristic and power of our generated multiplier, and we have 3 buttons to can choose architecture with whom we want generate our multiplier. It's black box first architecture, summator and other second, and with internal detailed realization, it says third architecture. And here in the right side we can see our scheme of our multiplier. It has input a, b, p, it's our polynomial, and has output of its result. And here is class diagram of my generator. I show here only for first architecture because I have no so many time for this. Only want to show you architecture of my generator, and we can see that it consists from classes generate function for F and generate function for modified guild cell. It generate these functions, and we use class transformation in and minimization to minimize our generated Boolean function with McCluskey method. And we have class create modified guild cell and create F. It generate visual description of these elements, and classes modified guild cell and F. that describe all inputs and outputs of our elements and connection between them. And class create matrix, it generate matrix from this element and generate visual description of it. And
Sorry, please next slide.
next. And here we can see how work our generator. It generates these multipliers, and it can be small, big, very different. Yes, and here it's testing of multipliers, and we can see that I did this. I have found this result is in Maple. I used Galois field with characteristic 3 and power 30 and used two elements A, B and polynomial, and we can see that result that was in Maple is the same like result in time diagram that was in ActiveHDL. You can see that result is the same. And in the second two we see we used Galois field with characteristic 7 and power 17, and two we can see that result is the same like in Maple. And third third scheme, we use Galois field with characteristic 23 and power 10, and 2 we can see that result in Maple is the same like result in time diagram generated in ActiveHDL. And future works, the positive results of the core generator and the multipliers verification serve as a founded for the development of enhanced information security system based on elliptic course, particularly in post-quantum cryptography tools. And conclusion. The article is dedicated to testing the developed multipliers generator for extended for elements of extended Galois fields. The testing results of the generated multipliers for Galois fields 3 power 37 power 17, 23 power 10, 53 power 8, which have approximately the same order and are provided. The testing was conducted through simulation in the ActiveHDL environment to verify the correctness of the results. The simulation outcomes were compared with the multiplication result using the Maple mathematical package. The study demonstrates that the Galois field element multiplier generator generates accurate description of multipliers which all possible types of structures. Testing was carried out for 3 architectures for building modified guild cell for Galois field multipliers. That's all. Thank you. Maybe you have a question.
Thank you very much for your very interesting report. Dear colleagues, have you any questions, reporter?
Hi everyone. I
Hi.
have some questions.
Yeah.
What is the practical application of your approach?
I wanted to research more wide using of extended Galois field, and I wanted to know how hardware complexity is for different multipliers for different with different characteristic and different power, and I should create this generator because I wanted to compare very much different multipliers, and I did this for that reason, to compare hardware complexity for multipliers with different characteristics.
Thank you very much. My second one question. What is the stages of implementation of your approach for practical application?
I generate only multipliers, and it's part of information security devices, and this is the more complexity part of it. Multiplication in Galois fields is a very difficult operation, and I concentrate only on this, on multipliers with Galois fields, extended Galois fields.
Thank you very much for your answers.
Thank you.